For millennia, we've gazed at the night sky, wondering if we're alone. Today, August 6, 2025, NASA has released the first detailed images of Proxima Centauri b, our closest exoplanetary neighbor. These aren't artists' impressions or blurry dots, they're real portraits of a world just over 4 light-years away. For the first time, we're not just detecting distant planets, we're seeing them, mapping their surfaces, and analyzing their atmospheres. This leap is the result of decades of innovation and global collaboration. The light from Proxima b began its journey to us over 4 years ago, and now we're finally seeing its message. We've built a telescope capable of revealing a world orbiting the nearest star to our Sun. The data we're gathering will redefine our understanding of Proxima b and guide our search for life elsewhere. We are the generation that has moved from imagining other worlds to observing them directly. The cosmos has invited us to look, and we have finally accepted the invitation. Our journey to the stars has truly begun. To grasp the impact of these images, we need to understand Proxima Centauri b. It's our closest known exoplanet, orbiting the red dwarf Proxima Centauri in the Alpha Centauri system. Unlike its sun-like companions, Proxima Centauri is dim and volatile, making its planet's environments harsh. Proxima b was discovered in 2016 by detecting its gravitational tug on its star. It's a rocky planet, at least 1.17 times Earth's mass, orbiting close to its star, completing a year in just over 11 Earth days. This tight orbit places it in the habitable zone, where liquid water could exist. But its proximity also means it's likely tidally locked, one side in endless day, the other in perpetual night. The planet faces intense stellar flares and radiation, raising questions about its habitability. For years, scientists debated whether Proxima b was a potential cradle for life or a barren rock. Now, with direct data, we can finally begin to answer those questions. Theories are giving way to evidence. The search for life just got a lot more interesting. Capturing a direct image of an exoplanet is a monumental technical feat. NASA used the James Webb Space Telescope, equipped with a cutting-edge coronagraph, to block Proxima Centauri's glare and reveal the faint light of Proxima b. Webb's infrared sensitivity was crucial for detecting the cool planet's glow. To sharpen the view, data from ground-based observatories like the Very Large Telescope in Chile were combined using long baseline interferometry, creating a virtual telescope of immense power. Months of careful observation and sophisticated algorithms filtered out noise and stitched together the planet's faint signals. This collaboration between space and ground telescopes turned a single pixel into a genuine image. The result, a triumph of technology and teamwork, revealing the face of another world. We've moved from speculation to direct observation. The universe is no longer out of reach. The new images of Proxima b are stunning. We see a crescent world, its dayside and nightside sharply divided, confirming it's tidally locked. The dayside isn't a scorched wasteland. Instead, it shows varied terrain. Bright highlands, dark plains, and a dramatic impact crater dubbed the Eye of Proxima. Most intriguing is the Twilight Terminator Zone, where spectroscopic analysis reveals a thin but persistent atmosphere and the signature of water vapor. This suggests a narrow band where temperatures could allow liquid water to exist. The massive crater hints at a violent history, while the planet's overall dark, ruddy hue reflects its rocky surface and red dwarf sunlight. Proxima b absorbs most of the light it receives, affecting its climate and temperature. For the first time, we're measuring these properties directly. The planet is no longer a mystery. It's a real, complex world. Each image brings us closer to understanding its nature. The mission's data gives us a detailed profile of Proxima b. Its diameter is about 14,500 kilometers, slightly larger than Earth, and its density suggests a rocky, metal-rich composition. Atmospheric readings show a surface pressure about 10% of Earth's, mostly nitrogen and carbon dioxide, with notable water vapor. The dayside reaches 120 degrees Celsius. The nightside drops to 150 degrees Celsius, but the Terminator Zone ranges from 10 degrees Celsius to 30 degrees, perfect for liquid water. The planet's orbit is nearly circular, with an 11.186-day year and almost no seasons. These numbers let us build accurate climate models and assess habitability. Proxima B's stability and unique climate make it a prime candidate for further study. We're no longer guessing, we're measuring. The building blocks for understanding alien worlds are finally in our hands. These observations have upended our assumptions about Proxima B. Once thought to be a sterile, airless rock, it now shows signs of a thin atmosphere and water vapor. This proves that planets around red dwarfs can retain atmospheres, even in harsh conditions. The presence of water hints at a history of retention and possible habitability. Complex surface features suggest geological activity, perhaps even tectonics or volcanism, vital for climate regulation. Proxima B is not a dead world, but a dynamic system with surface, interior, and atmospheric interplay. The debate now shifts from if it could support life to where on the planet life might exist. The Terminator Zone is the prime suspect for habitability. We've moved from possibility to plausibility. Proxima B is now a leading candidate in our search for life beyond Earth. Proxima B redefines what we mean by habitable zone. Its tidally locked nature creates a world of extremes, one side scorched, the other frozen. The thin atmosphere limits heat transfer, making the Terminator Zone a narrow refuge. Yet, this balance may be just right. Enough atmosphere for water, but not so much to trigger a runaway greenhouse effect. Life here would exist in perpetual twilight, under a dim, red sun. Any photosynthetic organisms would need to be highly efficient, perhaps using pigments unlike anything on Earth. The constant light would create an alien rhythm for any ecosystem. Proxima B teaches us that habitability may be found in the margins, not across entire planets. The Terminator Zone could be the most common habitable environment in the galaxy. We must broaden our search for life to include these unique worlds. Proxima B is our first real laboratory for studying such extremes. The universe may be full of just right places, hidden in the twilight. Proxima B's discovery reshapes the search for life in the universe. Red dwarfs, once dismissed, are now prime targets. They're the most common stars in the Milky Way. If Proxima B can host an atmosphere and water, there could be tens of billions of similar worlds. The odds of finding life just increase dramatically. Future missions will focus on red dwarf systems, searching for atmospheric and water signatures on tidally locked planets. Proxima B is now the template for these investigations. The next step hunt for biosignatures, chemical fingerprints of life, in its atmosphere. For the first time, we can test for life on another world. Proxima B gives us a crucial point of comparison, showing that life's recipe may not be unique to Earth. If life exists there, it could be common throughout the cosmos. The observation of Proxima Centauri b marks a turning point in our cosmic exploration. We've transformed a distant point of light into a tangible, complex world. The next phase: deeper atmospheric analysis, searching for signs of life. Future telescopes will target Terminator zones on red dwarf planets. The dream of sending a probe, once science fiction, now feels within reach. Proxima B's true nature challenges our assumptions and inspires new questions. As we absorb this new portrait, we're reminded, if this is our neighbor, what wonders await us farther out? The journey has only just begun.